Welcome to part 4 of Competency 4. In this video, we will work with relations and functions. Okay, use the coordinate grid below to answer the questions that follow. Number 1, the graph of a line not shown with the equation y equals mx plus b, where m and b are negative constants, has points in which of the four coordinates above? Okay, let's think about this. If they're negative, we would actually have this. Y equals, let's say negative 1x minus 1. Okay? That being said, that means that our intercept would be negative 1, and then let's see here, where would it cross? Let's do this. Watch. Use your table, clear everything out, and put in negative. Well, we could just say negative x or put in negative 1x. Either way, you're correct, okay? Then minus the 1. Now let's push enter. We want to start at 0 and we want to go in steps of 1. Let's look at what our table gives us. Okay, yes, we have 0, negative 1, but I want you to notice something. As we go up, there's my negative, so I have negative 1 and 0, so that would be right there. Now, before I look at my calculator any further, all we need are 2 points to create a line. And in this case, my line will go through these 2 points and up. And let's pretend like I can draw a straight line. Okay? Notice that my line never goes into quadrant 1. Okay? And that's what we need to look for here. We need to mark out everything that has quadrant 1. Well, that only leaves option D. Now let's arrow up and down. So what should the coordinates of quadrant 1 have? Well, that's plus plus. So I should have a positive x and a positive y. Well, look, none of my ordered pairs are negative at the same time, and they're not. Actually, we can get negative at the same time. I'm sorry, but they're never positive at the same time. Okay, it depends on how I change my line, how negative it is. Okay, now let's see here. We have 1, 0. We could change it to where it is, but you see my point. It's option D. They can't be positive at the same time because then it wouldn't satisfy. Okay, all right. We could, let's say make it y equals negative x minus 5 and see what happens. Okay, either way, both have to be negative, and that's the point of all this. Let's see, let's make it 5, push enter, start at 0, and let's see where we go. Okay, as you see, we can have negative and negative at the same time. We just can't have anything positive at the same time. And as you go up and down, you see that just simply does not happen. Okay, let's look at number 2. Okay, the graph of a line not shown. So they're giving us the same kind of a problem with equation y equals a x squared plus b, where A and B are negative constants, has points in which of the four quadrants above. Okay, now this is going to be a different situation because of that square. So we would have y equals negative x squared. And let's see, it says both negatives, so let's make it minus 1. Okay? What would that look like? Well, we'd have to draw it, and then it would go down, and they're both negative. Okay, well, let's take a look. I'm going to back. Okay, there we go. Now I'm going to clear that out. I'm going to say negative x squared and minus 1. Okay, I want to go with the smallest intercept that's negative that I can. Okay, now, and I have to keep the form they gave me, because if I change the form they gave me, then things aren't as easy. Okay, it wouldn't be as straightforward. Okay, let's push enter, and let's start at 0, and let's see what happens. Okay, we have 0 and -1. So that means we're under our entire curve. Our quadratic points down, and it's under the x-axis. So notice that we don't have a plus together. So looks like plus plus doesn't happen. So that's quadrant 1. So we're going to have to mark that out. And then we don't have a negative and a negative at the same time. Yeah, you can go up and down and verify, but you can also look at your picture and verify. So this means anything with quadrant 1 or 2 has to be out. Well, that's not good. That's not good. That's not good. And again, looks like it's option D. Okay. And that's because of the conditions placed on us. All right, let's look at number 3. Number 3, what is the domain and range of the relation? Okay, now they've listed out S is our relation with ordered pairs. Okay, so the domain would include any x value. Okay, so we have -3, 2, -3, and 0. Okay, for the -3s, we only write that once. Okay, so let's look at option A. That is -3, 1, 2. Okay. No, I'm going to have to disagree with A. We want -3, 2, 0. B, that's not correct. -3, 2, 0. I would say option C. Let's check D. Nope. I completely disagree. Okay. Now, for the range, we need all these y values. Okay. So let's check. We have 2, 1, then 4, then -3, which is correct. Okay, let's look at number 4. Oh, actually, before that, let's scoot up just a smidge. Okay. Given the relation R is equal to 3, 6, 9, 3, and 7, and we have a blank. Which number can be placed in the blank that will allow R to become a function? Okay. Now we know the properties of a function mean that we want it to be a function, mean that none of the x values repeat. Wait a second. So that means the domain cannot have repeating values. Well, let's look at what we have. We have 3, 9, and 7. Those don't repeat. It's a trick question. I could put a smiley face here, and that would still be a function. By the definition of a function, it doesn't matter what I put in the blank. That being said, option D, satisfied. You can put them all in there. Actually, you could put 637 in there. You could combine the digits to an actual number, and there you go. You would have a function. Okay, let's look at number 5. Given y equals x squared, which of the following is true regarding the relation? First off, I need to make a comment. That relation is a function. X squared is a quadratic. that points up. And if we want to use the vertical line test, no matter where we put our line through, we only hit the function, or rather the quadratic, once. Therefore, it is a function. So we need to go through and talk about each of these. A, the relation is not a function since it is squared. Being squared has nothing to do with the definition of being a function, and it is a function. It passes a vertical line test. Okay, now B, the relation is a function since each x value in the domain has only one y. I agree with this, okay? Because let's look at our image. That means that you're not going to have another dot here, or say here, or over here that your line will go through, as well as going through the quadratic itself. So it only goes through one y value, not three, not four, just one. Uniquely, it will hit one y value. Okay, that being said, I say B's it, but let's read C and D. C says the relation is a function set since some y's in the domain. Oh, that's messed up. Y's are not in the domain. Have the same x value. Well, they've made a mistake within their statement. And if you miss that, you might be tempted and get confused with the properties. So I'm going to mark that out because we have a serious discrepancy here. And let's look at D. The relation is not a function. Oh, but it is a function. So we have to mark that out, okay? And let's prove it to ourselves. Let's go to our table, clear everything out, and say y squared. Push enter. Start at 0. It doesn't matter. Okay, remember, what was the rule? When we look at our x values and we arrow up and down, we should see that the x, for the x's, we don't have another y, a same y, a repeating y. Let's take a look. Because the y's can't repeat, so the x's can't have the same y values. Okay, you really have to think that out. It sounds so confusing when I say it. Let's look at this visually. I'm going to push enter. I want steps of 1. Okay, notice I have 0, 0. Well, I believe that is okay because that's the vertex. Okay, now watch. Okay, I have 1, 1, and 2, 4. Go up. 1 for my y is at -1. And 4, y equals 4, has an x of -2. Let's go and see. Well, when I have 4 over here with my y, I have +2. I do not have a -2. So we don't see that repetition anywhere. Okay, that verifies what B is saying. The relation is a function since each x value in the domain has only one y. Okay, it doesn't have repeated y's. Okay, all right. You what you might mistake is that if you have a repeated y, you can't do that. Well, look, this 4 goes to +2 as 1 goes to 1. But when we have 1 in the y, it goes to a -1. So it is a unique situation for those values, okay? All right, so B is what you need to answer on that. All right, so let's look at number 6. Number 6, which of the following does not represent a function? As we discussed before, if you have repeating x values, it cannot be a function. Okay, so let's look at A. Well, 3972. No repeats. That is a function. That's not what we're looking for. Okay, y equals 3x plus 7. That's a function because it's a straight line. And when you have a straight line, other than being undefined, those are all functions. Okay, and you can put this in your calculator. 3x plus a 7. Oh, no, no, no. I am so sorry. The first thing you need to do is push table and clear it. Now 3x plus 7. In my mind, I was already in table. Now let's push enter. Start at 0. Count by 1, steps of 1. And let's put that in. And now take a look. You're not going to see anything repeating. Okay? And think about it. Even if I have a line going up or a line going down, even y equals with 0 slope. No matter what, that's a function because if I draw like this, I only hit the line once. Okay? Since it is a solid defined y equals mx plus b form, all of those in the y-intercept form, they're all functions. So that we need to mark out. Okay? Right? So now let's look at C. You might be tempted to say that that's not a function, but you need to know what that looks like. It looks like this. Okay? And here, that would be your origin. So at no point is it undefined. It's going to be a nice, smooth decreasing, increasing, and the vertical line test will be passed. It will only, if you try the test, you're only going to hit that line once. So that is a function. Okay, well, D better not be a function because that's all we have left. Okay, I'm going to go ahead and say we need option D, and I know why. I mean, I already know. I'm looking at it. That is the equation of a circle. Okay, and our calculator won't help us with that. This is one of these things. I mean, there's ways to manipulate it, but I'll be honest with you, you need to recognize all of your curves. This is a circle, okay? And a circle cannot be a function. All right, there's just no way it's a function. And if we look at number 7 below, I'm going to go ahead and just skip to it, and that kind of proves our point here. Okay? Number 7 says, which of the following graphs represents a function? Well, verifying what D had, I mean, the circle is a little different from D, but it doesn't matter. A circle's a circle. We're going to hit twice. We go down, and it definitely does not pass the vertical line test. So this, it B's out. Okay? Now, let's look at A. A is um, kind of a shifted and flipped over, whatever you want to say, a negative uh, that comes from the parent function x to the third. Okay, and we know that's a function. So if we go and try to perform our line test, it passes. So that is a function, 100%. Now, C, that will not. That's part of a hyperbola. No, that will not pass. So that's out. C's out. Now let's look at D. You might have been looking at D going, well, is that going to pass the vertical line test? And what about this big gap? The gap doesn't matter. Not when we're testing for a function. Okay? What matters is that when we try to perform our line test, when we come right here and go through, we hit two dots. Two dots, closed ends are 2 points that our line goes through, that invalidates it. It cannot be a function. Okay? All right. This is the last question in for this video. I wanted to thank everyone for watching and making it to the end. You are so appreciated, and I hope you have success. So happy testing.